June 1943, Vienna, Austria. The summer heat pressed against the stone walls of St. Karl Borromaeus Church as Father Heinrich Maier unfolded a set of technical drawings across his desk. His hands, meant for blessing congregants, now traced the curved lines of the world's first ballistic missile, the V2 rocket, a machine so advanced that Allied intelligence couldn't decide if it even existed. These weren't rough sketches, they were exact specifications, fuel mixture ratios, thrust calculations, combustion chamber dimensions, everything. Father Maier was 35 years old, a Catholic priest with a doctorate in philosophy. He had taught at Vienna's finest schools before the Anschluss swallowed Austria whole in 1938. Now he led something more dangerous than any sermon, the Maier-Messner resistance group. A network of Austrian patriots who had decided that every bomb falling on Nazi armament factories was a prayer answered, that shortening this war by even one day was worth any risk, and the drawings before him represented intelligence so valuable that it could reshape the entire Allied bombing campaign. Maier ran his finger along the technical specifications one more time before rolling up the documents. His contact would arrive in an hour, time to prepare the handoff that would cost him everything. Germany still occupied most of Europe. German armies still fought from the Arctic to North Africa. But beneath the surface, the balance had shifted. The Reich's technological edge was slipping. American industrial production had become an unstoppable flood. The Soviets had learned to build tanks faster than Germany could destroy them. And British intelligence networks were slowly, methodically unraveling every German secret. But one weapon still kept Allied commanders awake at night. The rocket. Reports had been filtering into London since early 1943 about some kind of revolutionary weapon being developed at a place called Peenemünde on the Baltic coast. Polish resistance fighters sent fragments of information. 2 Polish janitors working at Peenemünde's Camp Trassenheide managed to provide sketches to Polish Home Army intelligence. They identified a rocket assembly hall, an experimental pit, and a launching tower. But British intelligence remained divided. Some analysts believed the reports, others thought the whole thing was an elaborate German deception. How could anyone build a rocket that weighed several tons, traveled at supersonic speeds, and struck targets nearly 200 miles away? The physics seemed impossible. The fuel requirements alone would be staggering. No known propellant could provide that much thrust. The skepticism among Allied intelligence officers wasn't simple denial. It was rooted in legitimate technical understanding. The V2 represented a quantum leap beyond anything previously attempted. Consider the engineering challenges. A liquid-fueled rocket engine operating at extreme pressures. Guidance systems maintaining accuracy over 200 miles. Supersonic aerodynamics that no wind tunnel had adequately tested. Fuel pumps delivering thousands of gallons per minute. And all of this had to be packaged into a weapon that could be mass-produced, transported to launch sites, and fired by artillery crews with minimal training. The technical barriers seemed insurmountable. This was the intelligence fog that Father Heinrich Maier decided to penetrate. He understood something that many resistance fighters did not. Technical details mattered more than heroic gestures. Location sketches of factories were worth more than 100 sabotage attempts. Precise production numbers could guide Allied bombers to the exact buildings that needed destruction. This wasn't romantic resistance. This was methodical intelligence work, and it required access to people who understood weapons production at the highest technical levels. Maier had built his network carefully over years, not months. At the center was Franz Josef Messner, Director General of Semperit, one of Austria's largest industrial corporations. Semperit manufactured rubber and synthetic materials. Their plants produced components for German tanks, aircraft, and rockets. Messner had access to technical specifications that most German officers never saw. He knew production numbers, factory locations, supply chains, raw material sources, manufacturing bottlenecks, quality control failures, all the mundane details that transformed abstract intelligence into actionable targeting data, and he hated the Nazis with a quiet, burning fury that matched Maier's own. Messner was a businessman who had watched the Nazis dismantle Austrian independence, who had seen Jewish colleagues dismissed, arrested, deported, who understood that every day this regime survived was another day of murder on an industrial scale. The two men had formed an unlikely partnership, the priest and the industrialist. one providing moral conviction, the other providing technical intelligence, each understanding that their collaboration represented the most effective form of resistance available to them. The network expanded from there through careful recruitment. Walter Caldenazzi, a student at the University of Agriculture in Vienna, used his physical limitations as cover. He walked with a cane due to a childhood injury that left him with a pronounced limp. Nobody suspected the limping student of being an intelligence courier. Security officers assumed his disability made him harmless. They were catastrophically wrong. Caldenazzi moved through Tyrol collecting information from armaments factories in Jenbach, where drive components for the Messerschmitt III Comet rocket-powered interceptor and V2 rockets were manufactured. He established contacts with Italian construction workers who had their own resistance connections across the border. Information flowed through this network like electricity through a circuit. Technical drawings, production schedules, factory layouts, quality control reports, shipping manifests, all of it finding its way back to Maier's church through routes that changed constantly to avoid detection. Then there was the Austrian officer who provided the breakthrough that made everything possible, Lieutenant General Heinrich Stumpfel, the commandant of Vienna. A former officer of the Austro-Hungarian army, Stumpfel represented the old Austria, the multinational empire that Hitler had destroyed and replaced with his vision of Greater Germany. Stumpfel was a professional soldier who had sworn oaths to Franz Josef, not Adolf Hitler. He knew about Maier's activities. He knew about the intelligence network operating right under German noses in the heart of Vienna, and he chose to help. Stumpfel provided access to restricted military areas. He looked the other way when certain documents went missing from military offices. He created the protective cover that allowed the resistance group to operate. He understood that his career, his freedom, his life were forfeit if the Gestapo discovered his involvement. He helped anyway. This was the forbidden trick that the title hints at. Not a single German scientist defecting with briefcases full of documents in some dramatic midnight escape, but an Austrian resistance network using connections within the Nazi military infrastructure itself to extract the most closely guarded technical secrets of the war. They were operating inside the system, using the system's own access controls and security clearances against itself. Every classified document that crossed Stumpfel's desk was potentially available to Maier's network. Every factory inspection that Messner conducted for Semperit business was an intelligence-gathering opportunity. Every construction site that Caldenazzi visited was a chance to photograph facility layouts. The network had penetrated German security at multiple levels simultaneously. The V2 rocket that Maier's network was exposing had been under development since the 1930s. Its technical director was a young engineer named Wernher von Braun. Born into Prussian aristocracy in 1912, von Braun had become obsessed with rockets as a teenager after reading Hermann Oberth's book on space travel. The idea that humanity could escape Earth's gravity well captured his imagination completely. By 1930, at age 18, he was conducting rocket experiments that caught the attention of the German army. By 1932, at age 20, the German army had already noticed his talents and offered him everything a young engineer could want: unlimited funding, the finest facilities in Germany, access to the best minds in rocket science, a chance to push the boundaries of what was technically possible. All he had to do was build weapons for the Reich. Von Braun accepted without apparent hesitation. He joined the Nazi Party in 1937. He accepted a commission as a junior SS officer in 1940, eventually reaching the rank of Sturmbannführer, equivalent to major. He told himself it was necessary for his work, that he was really building rockets for space exploration, not for killing people, that the military applications were just temporary funding sources for his true passion. But by 1943, there was no ambiguity left. The weapon he had created was designed for one purpose: to strike civilian populations with unstoppable force, to terrorize British cities, to demonstrate that Germany still possessed technological superiority even as its armies retreated on multiple fronts. The rocket was officially called the Aggregate 4, or A4, indicating it was the fourth major design in a series of experimental rockets. Later, it would be renamed Vergeltungswaffe 2, Vengeance Weapon 2, the V2. The name itself was propaganda, suggesting that Germany was exacting revenge for Allied bombing of German cities. Never mind that the Luftwaffe had pioneered strategic bombing of civilian targets in Poland, Rotterdam, and London. Never mind that German V-weapons were explicitly designed to strike population centers rather than military targets. The vengeance narrative played well with German civilians who were enduring nightly bombing raids by the Royal Air Force. The engineering behind the V2 represented a genuine revolution in military technology. The rocket stood 46 feet tall and weighed nearly 28,000 pounds at launch, of which approximately 18,000 pounds was propellant. Its engine burned a mixture of 75% ethanol and 25% water for fuel, with liquid oxygen as the oxidizer. This propellant combination was itself a masterpiece of chemical engineering that had taken years to perfect. The water content reduced flame temperature from over 5,000 degrees Fahrenheit to a more manageable 3,500 degrees, acted as a coolant by turning to steam, and augmented thrust through steam expansion. It produced a smoother burn by suppressing combustion instabilities and reduced thermal stress on the combustion chamber walls. The engine generated approximately 56,000 pounds of thrust at sea level, enough to push the rocket to altitudes of over 50 miles and speeds exceeding 3,500 miles per hour, more than 5 times the speed of sound, Mach 5 in the thin air of the upper atmosphere. The guidance system was equally sophisticated and represented innovations that wouldn't appear in Allied missiles for years. Gyroscopes maintained the rocket's orientation during flight, measuring rotation rates around 3 axes with remarkable precision. A radio control system measured velocity using Doppler tracking by transmitting a signal from the ground, receiving it back from a transponder on the rocket, and measuring the frequency shift to calculate velocity. This system signaled the engine to cut off at precisely the right moment to reach the target. The timing had to be exact. Cut off too early and the rocket fell short. Too late and it overshot. Heat-resistant graphite vanes in the exhaust stream acted as rudders, controlling trajectory during the critical first seconds after launch, when the rocket was moving too slowly for aerodynamic control surfaces to function effectively. 4 external fins provided aerodynamic stability once the rocket reached sufficient speed. The entire system represented engineering at a level that Allied scientists had barely imagined. But it also had weaknesses that Maier's intelligence network was about to reveal. The guidance system was complex and prone to failures. The liquid oxygen boiled off rapidly, requiring rockets to be fueled immediately before launch. The fuel pumps, driven by a steam turbine powered by decomposing hydrogen peroxide, were finicky and unreliable. The alcohol fuel depended on potato harvests for production. The entire weapon required an extensive ground support infrastructure, including specialized transport vehicles, launch platforms, fuel tankers, and trained crews. These vulnerabilities meant the V2 could be disrupted at multiple points in its production and deployment chain. By the spring of 1943, Maier had established contact with Alan Dulles, the director of the Office of Strategic Services Station in Switzerland. Dulles would later become director of the CIA and would be remembered as one of the most effective intelligence officers of the 20th century. But in 1943, he was America's most important spy master in Europe, operating from the neutral territory of Switzerland, where he could maintain contacts across multiple countries. He had heard rumors of an Austrian resistance group providing technical intelligence, but he remained deeply skeptical. Too many resistance networks turned out to be either German plants running double-agent operations or well-meaning amateurs with more courage than competence, who provided intelligence that was enthusiastic but inaccurate. Then Maier's courier arrived with the first package in late 1942. Dulles opened it expecting the usual mix of rumor, speculation, and third-hand reports. Instead, he found technical drawings of remarkable precision. The documents showed V2 production facilities with engineering quality detail, exact locations of assembly plants at Peenemünde, Friedrichshafen, and the newly built Raxwalk facility. They included factory layouts detailed enough for targeting purposes, showing the location of specific production lines within large industrial complexes. Specifications for the missile's guidance system, written at a level that suggested access to actual design documents. Information about the supersonic wind tunnel where aerodynamic testing was conducted, including the test parameters and results. Production schedules indicating that Germany planned to build 2,000 rockets per month once manufacturing reached full capacity. quality control reports showing current failure rates and the technical problems still being solved. This wasn't amateur intelligence gathering by enthusiastic partisans reporting what they'd heard in taverns. This was professional-grade technical espionage conducted by people with direct access to classified documents and manufacturing facilities. Dulles sent an encrypted cable to Washington. He had found a source of much of the technical information on the rockets. The Maier-Messner group became one of the OSS's most valuable intelligence assets in Austria. Dulles signed Messner to a formal contract, providing funding and establishing secure communication protocols. The resistance group even received a code name from the Americans, CASSIA. To the Austrians themselves, they were simply the Austrian Committee of Liberation. But getting the information out of occupied Austria required more than just collecting it. The group needed couriers who could move through German security checkpoints without arousing suspicion. They found one in Tula Isakides, a Greek soprano who performed at the Vienna State Opera. Her concerts provided perfect cover for international travel. Opera singers moved between neutral Switzerland, occupied Austria, and even fascist Italy as part of their professional duties. In late 1942, while performing in Switzerland, Isakides established direct contact with Dulles in Bern. She hand-delivered intelligence that her network had been accumulating for months. Dulles was impressed enough by the quality and detail of the intelligence to sign Messner to a formal contract with the OSS on the spot. The intelligence kept flowing throughout 1943 with increasing volume and precision. Location sketches of steel mills showing which blast furnaces produced armor plate versus structural steel, weapon factories with building-by-building breakdowns of what was manufactured where, ball-bearing production facilities including daily output numbers, information about German synthetic rubber production using the Bunner process, with details on chemical feedstocks and production capacity. Aircraft manufacturing plants with specifications on which types of aircraft were being produced and at what rates. The group tracked down information about the Wiener Neustadt aircraft factory, the largest and most important German fighter aircraft production facility of that era, producing Messerschmitt Bf-109 fighters at a rate exceeding 1,000 per month. Each piece of intelligence was meticulously verified before being transmitted. Maier insisted on multiple independent sources for any significant claim. He understood that inaccurate intelligence was worse than no intelligence because it could lead Allied bombers to strike the wrong targets, wasting bombs on empty buildings while real production facilities continued operating. As he told his interrogators later, after his capture, he wanted to prevent Allied airstrikes on Austrian cities by providing information about armaments factories. He hoped this would spare other industries that Austria would need after the war. He hoped it would protect civilian populations. Every bomb that falls on armaments factories shortens the war and spares the civilian population. That was his principle, repeated often to his network. It would cost him his life. The most significant intelligence breakthrough came in late June 1943. The exact technical drawings of the V2 rocket arrived through Stomfel's network, not sketches based on second-hand descriptions, not approximations from external observations. Complete engineering specifications drawn from actual design documents. These showed Allied analysts exactly what they were facing: the rocket's precise dimensions, its exact fuel requirements, its guidance system architecture, its production complexity and the specialized equipment required for manufacturing, its operational vulnerabilities and the ground support infrastructure needed for deployment. British intelligence had been conducting Operation Crossbow, a joint photographic interpretation effort to locate V-weapons laboratories and production facilities. American reconnaissance squadrons from the 8th Air Force's 13th, 14th and 22nd Photo Reconnaissance Squadrons were flying missions over Peenemünde, pushing the limits of 1940s photographic technology to capture images through cloud cover, haze and German air defenses. They were using specialized Spitfire and Mosquito aircraft flying at altitudes above 30,000 feet where German fighters struggled to intercept them. The cameras were state-of-the-art, but even the best aerial photography could only reveal so much. Buildings, yes. General activities, yes. One British intelligence analyst later described the impact of the Austrian intelligence in a classified report. They had been arguing for months about whether a liquid-fueled rocket of this size was even possible. Some analysts thought the Polish resistance reports were exaggerated through multiple retellings. Others suspected German deception, pointing out that the Nazis had successfully used dummy tanks and fake airfields to mislead Allied reconnaissance before. A few even suggested the entire Peenemünde facility was an elaborate ruse to draw Allied bombing away from more important targets. The Austrian intelligence ended the debate conclusively. The rocket was real, it was advanced. It was nearly ready for mass production, and more importantly, it was vulnerable at specific points in its production and deployment chain. The drawings showed that V2 production was concentrated at specific facilities that could be targeted by strategic bombing. The research center at Peenemünde, where design work and testing occurred, the underground factory being constructed in the Harz Mountains at a site called Mittelwerk, where final assembly would take place. The fuel production facilities where ethanol and liquid oxygen were manufactured. The guidance system production plants where gyroscopes and radio equipment were built. The specialized steel mills producing the high-strength alloys needed for the combustion chamber and fuel tanks. Each of these was a potential target. Disrupt any one of them and the entire production chain would slow. Allied bombing planners could now target the exact components that would cripple rocket production most effectively. The British moved fast once they had confirmation. Duncan Sandys, Churchill's son-in-law and a former artillery officer who had been injured in a car accident that left him with a permanent limp, was placed in charge of investigating the rocket threat. He had the technical knowledge from his artillery background to understand the intelligence. He had direct access to Churchill himself through family connections. No bureaucratic delays, no chains of command to navigate. When Sandys said something needed Churchill's attention, it got there immediately. In June 1943, Sandys ordered immediate reconnaissance flights over Peenemünde using the latest photographic equipment and the most experienced reconnaissance pilots available. A photo interpreter named Constance Babington Smith had been studying earlier reconnaissance images at the Central Interpretation Unit at RAF Meticulously. She was one of the few women in aerial photo interpretation, having joined in 1940 despite initial resistance from male officers who doubted women could handle the technical work. She had proved them wrong by identifying German aircraft types and military installations with uncanny accuracy. She thought she had spotted something unusual at Peenemünde in earlier photographs. Strange circular emplacements that didn't match known German military installations, scorch marks on the ground that suggested rocket exhaust, construction that looked like test stands. But without context, she couldn't be certain what she was seeing. Now, with the Austrian intelligence providing technical specifications and facility layouts, she knew exactly what she was looking for. She leaned over the new photographs with her stereo magnifier, an optical device that allowed three-dimensional viewing of overlapping aerial photos, and there it was, a rocket lying horizontally on its transport trailer near a launch emplacement. A vertical column about 40 feet high that matched the dimensions from the Austrian drawings exactly. Evidence of rocket exhaust on the test stands, showing the characteristic pattern of supersonic combustion. Construction work consistent with assembly buildings and fuel storage facilities. She wrote her report immediately, attaching the photos with annotations identifying each component. This was no hoax, this was no deception, the threat was absolutely real. Churchill's top scientific advisors remained divided even with this evidence. Professor Frederick Lindemann, Churchill's chief scientific advisor and a close personal friend, dismissed the reports. He argued that a rocket of this size was impractical from an engineering standpoint, that the fuel requirements made it economically unfeasible as a weapon, that the Germans were wasting resources on fantasy weapons while losing the real war. Lindemann was a brilliant physicist, but he was also arrogant and dismissive of intelligence that contradicted his own technical intuitions. But other analysts disagreed strongly. The photographic evidence, combined with the Austrian technical intelligence, was too compelling to ignore. The Poles were reporting similar findings from their position near the Blizna test site. Multiple independent sources were converging on the same conclusion. Churchill made his decision in July 1943 after reviewing the evidence personally. Peenemünde would be attacked with maximum force at the earliest opportunity. Operation Hydra was scheduled for mid-August when weather conditions and moon phases would be optimal. The goal wasn't just to damage buildings, it was to kill the scientists and engineers who designed the rockets, to destroy the research documentation and test equipment. to delay the weapon's deployment by any means necessary. The operation would be executed regardless of cost. If the first raid failed, they would return the next night and the night after that until the target was destroyed. This was Churchill's explicit order. 596 aircraft took off from British airfields across eastern England. 324 Lancaster bombers, the backbone of RAF Bomber Command. 218 Halifax bombers, slightly lighter but with longer range. 54 Sterling bombers, older four-engine aircraft nearing the end of their operational service. Each aircraft carried a mix of high-explosive and incendiary bombs. The total bomb load exceeded 1,800 tons. The crews weren't told the real target until the final briefing to maintain operational security. They were told Peenemünde was developing advanced radar that threatened the entire bombing campaign. The truth about rockets would have been too sensitive, too revealing of Allied intelligence sources, too likely to leak through prisoners of war or intercepted communications. The briefing officer's words were blunt and memorable. If the attack fails, it will be repeated the next night and every night after, regardless of casualties, until the job is done. This is that important. The crews understood. This wasn't a routine mission. This was a maximum priority target that justified extraordinary risks. Some crews would not return. Everyone in that briefing room knew it. Shortly after midnight, the Pathfinder Squadron arrived over Peenemünde. These were the most experienced crews in Bomber Command, specially trained in precision navigation and target marking. They dropped coloured flares to mark the target for the main bomber force following behind. Werner von Braun was having drinks in the officers' club with Hannah Reich, Germany's most famous female test pilot, when the air raid sirens sounded. He didn't believe it at first. Peenemünde was supposed to be secret, its location unknown to Allied intelligence. It was too far from British bases for effective bombing, requiring a round trip of over 1,200 miles. But then the first bombs started falling. High explosive bombs that created massive concussions, incendiary bombs that started fires. The raid focused on 3 aiming points identified from the Austrian intelligence and aerial reconnaissance. The scientists' and workers' living quarters to kill irreplaceable technical personnel. The rocket factory buildings to destroy production equipment. The experimental station with its test stands and research equipment to eliminate testing capabilities. The initial bombing fell south of the intended aiming point on a forced labor camp where prisoners were housed, killing hundreds of innocent people in the first few minutes. But the master bomber, an experienced pilot circling overhead and coordinating the attack, quickly recognized the error. The Pathfinders repositioned their marker flares. The main force adjusted their aim. Within 20 minutes, the real target areas were being systematically destroyed with much greater accuracy. One building after another erupted in flames. The rocket assembly works where V2s were being hand-built by skilled technicians. The supersonic wind tunnel where Professor Rudolf Hermann had been conducting cutting-edge aerodynamic research. The liquid oxygen production plant that supplied oxidizer for test launches. Machine shops filled with specialized equipment, drawing offices containing irreplaceable technical documentation, explosive test bunkers where propellant mixtures were evaluated, housing blocks where scientists and engineers lived. 2 key scientists were killed in the raid. Dr. Walter Thiel, von Braun's deputy director and the chief propulsion engineer, who had solved the combustion instability problems that had plagued early rocket engines. His death was a catastrophic loss because he possessed technical knowledge that existed nowhere else. Chief Engineer Erich Walther, the guidance system expert who had designed the radio control cutoff mechanism, hundreds of forced laborers and German workers died in the attack. The physical damage was extensive. Post-mission reconnaissance showed multiple buildings completely destroyed, others severely damaged, but the raid had succeeded in its primary objective. The real impact was psychological and strategic. The secret was out. The Allies knew about Peenemünde. They knew about the rockets. They knew enough to target specific facilities within the complex, and they were willing to commit massive resources to stopping rocket development. Von Braun himself stood outside after the raid, watching fires burn through what had been Germany's most advanced research facility. Some buildings were total losses, smoking ruins that would never be rebuilt. Others were damaged but potentially salvageable. The raid had succeeded, but it hadn't destroyed Peenemünde completely. More importantly, most of the technical staff had survived. The knowledge remained. But the message was clear. Peenemünde was no longer safe. German leadership drew the obvious conclusion immediately. Peenemünde was too vulnerable to continue as the primary rocket development and production site, too exposed to reconnaissance, too accessible to British bombers. Production would have to move underground where Allied aircraft couldn't reach it. The testing program would shift to a new facility being constructed in Poland, at a site called Blynia, far from British bomber bases. The secret weapons development would be dispersed across multiple locations to prevent a single raid from destroying the entire program. The Polish resistance would soon discover the new testing ground near Blynia and begin collecting rocket fragments that fell short of their targets in test launches. They would eventually smuggle an intact V2 rocket out of Poland to Britain in Operation Most 3. But that's a different story for a different time. What matters here is that the August 1943 raid bought time. 2 months during which the Allies strengthened their positions in Italy after the Sicily invasion. 2 months of preparation for the Normandy invasion that would open the Western Front. 2 months in which V2 rockets weren't falling on London, killing civilians and destroying morale. And that 2-month delay was directly traceable to the intelligence provided by Maier's resistance network. Without the Austrian technical specifications, Allied commanders might have continued dismissing the rocket threat as German propaganda or strategic deception. Without the factory location details and facility layouts, the bombing raid couldn't have been planned with such precision. Without the production schedule information showing that deployment was imminent, the urgency of the strike wouldn't have been clear. This was intelligence work that shaped military operations at the highest strategic level, but the Gestapo was closing in on Maier's network. The Germans had their own intelligence services, their own networks of informers planted within resistance groups. Resistance organizations always face the same fundamental problem. Every new member is both an asset and a vulnerability. Every contact is a potential betrayal point. Every successful operation leaves traces that skilled counterintelligence officers can follow. And the Maier-Messner group had grown large enough and operated long enough to attract serious attention from German security services. In late 1944, disaster struck with sudden, devastating completeness. Otto Hartmann, an actor at the prestigious Burgtheater in Vienna, had infiltrated the Catholic resistance network. He was a paid Gestapo informer who had been reporting on resistance activities for months. His information led to coordinated arrests of 10 key leaders of the Catholic resistance organization in a single night. All were taken to Gestapo headquarters. All were interrogated using torture methods refined through years of suppressing resistance across occupied Europe. All were eventually sentenced to death. Franz Josef Messner was arrested first in his Semperit office. The Semperit Director General, who had provided so much of the technical intelligence, who had risked everything to pass classified documents to Allied intelligence. He was sent to Mauthausen concentration camp in Austria. On March 22, 1945, with Soviet forces already approaching Vienna, he was murdered in the gas chambers. The Nazis killed him even though the war was obviously lost, even though his intelligence work had already accomplished its mission. Heinrich Maier was arrested shortly after Messner in a dawn raid on his church. The Gestapo interrogated him brutally, using methods designed to break even the most determined resistance. They wanted names of network members, contacts with Allied intelligence, operating procedures, communication methods, drop sites. The entire structure of his organization lay bare. Maier gave them nothing useful despite torture that left him barely able to walk. He had taught himself the principles of intelligence security through careful study. He had compartmentalized the network so that each member knew only what they needed to know for their specific role. He had established protocols that prevented any single arrest from compromising the entire organization. Even under torture, he couldn't compromise operations he had deliberately kept himself ignorant of. This was professional tradecraft applied by an amateur who understood that organizational security was more important than individual heroism. On March 22, 1945, the same day Messner died at Mauthausen, Heinrich Maier was executed in Vienna by firing squad. He was 37 years old. He would be recorded in Austrian historical records as the last person executed by the Nazi regime in Vienna before their final retreat. The war was essentially over by then. Soviet forces were advancing on Vienna from the east, already fighting in the city's outer suburbs. American forces were deep into Germany from the west, crossing the Rhine and advancing toward Bavaria. The Thousand-Year Reich had perhaps 6 weeks of existence remaining, but the Gestapo still found time and resources to execute a Catholic priest who had provided intelligence to the Allies 2 years earlier. The machinery of Nazi terror continued operating until the very end. Walter Keldenazzi, the limping student who had collected factory specifications across Tyrol, was also arrested and executed. Other network members were imprisoned or killed. The Austrian resistance network that had done so much to shorten the war was systematically destroyed in its final months. The network's contribution would remain largely unknown for decades, buried in classified files and obscured by the focus on the German scientists who built the rockets rather than the Austrian resistors who exposed them. The V2 rocket eventually did go into operation, despite the delays caused by Allied bombing and intelligence operations. The first combat launch occurred on September 8, 1944, when a single rocket was fired at Paris from a mobile launcher in occupied Holland. The rocket malfunctioned and crashed shortly after launch, a preview of reliability problems that would plague the weapon throughout its operational life. The next day, 2 more rockets were launched, this time aimed at London. One hit Staveley Road in Chiswick at precisely 6:04 p.m. It killed 3 people instantly in the initial blast: a 63-year-old woman named Ada Harrison who was in her home, a 3-year-old girl named Rosemary Clark playing in her garden, and sapper Bernard Browning, a young soldier on military leave who had been hurrying down the street to catch a train to see his girlfriend. There was no warning, no air raid siren, no sound of approaching engines, just a sudden, catastrophic explosion that carved a 20-foot crater in the street and destroyed 11 houses completely. The V2 had arrived as a weapon of terror. Over the following months, more than 3,000 V2 rockets would be launched against Allied targets by German artillery units operating from mobile launchers in Holland, and later from sites in Germany itself as Allied forces advanced. Most struck London and the Belgian port of Antwerp, where Allied supplies were being unloaded. The rocket travelled faster than sound, reaching speeds over Mach 4 during its descent, so victims heard nothing until after impact when the sound of the rocket's passage caught up. There was no defense against it. Fighters couldn't intercept something travelling that fast at that altitude. Anti-aircraft guns couldn't track a target with no radar signature moving at supersonic speeds. The only countermeasures were intelligence-based, targeting the launchers and supply infrastructure before launches could occur. British MI5 used their double-cross network of turned German agents to feed false information about V2 impact points. The double agents, German spies who had been captured and flicked to work for British intelligence, sent reports back to Germany claiming that V2 rockets were overshooting London by 10 to 20 miles. The Germans, believing this misinformation from agents they thought were still loyal, adjusted their targeting calculations to compensate for the reported overshoots. More than half the subsequent V2 launches aimed at London fell short as a result, landing in less populated areas of Kent rather than central London. This deception campaign saved thousands of lives by causing German gunners to systematically mis-target their weapons. But it couldn't stop the V2 entirely. The V2 ultimately killed approximately 2,700 people in Britain and 6,500 more in Antwerp and Liège. Each rocket cost approximately 100,000 Reichsmarks to produce in 1944 currency, the equivalent of several $1 million in modern terms. Germany built them using slave labor from concentration camps, primarily at the underground metalwork factory carved into the Harz Mountains. Approximately 20,000 prisoners died building V2 rockets. More people died making the weapon than died from its use. This was the terrible arithmetic of Nazi wonder weapons. Enormous resources poured into systems that had minimal strategic impact while consuming lives on an industrial scale. The V2 never changed the course of the war. It arrived too late, after Allied victory was already certain. It was too expensive, consuming resources that could have built thousands of conventional weapons. It was too inaccurate for anything except area bombardment of cities. German generals later admitted in post-war interrogations that the resources spent on V2 production could have built 8,000 fighter aircraft. Planes that might actually have defended German cities from the relentless Allied bombing campaign that was destroying German war production. Hitler himself had initially dismissed the rocket program in 1942 as merely an artillery shell with a longer range and much higher cost. He was right. But by 1943, desperate for any weapon that might turn the tide or at least terrorize the Allies into negotiations, he threw Germany's remaining industrial capacity behind rocket production anyway. It was a strategic blunder born of desperation. After the war ended with Germany's unconditional surrender in May 1945, American and Soviet forces raced each other to capture German rocket scientists and V2 hardware. Wernher von Braun and most of his core team deliberately surrendered to American forces in Bavaria. They calculated, correctly, that the United States offered the best opportunity to continue their work in the post-war world. Von Braun's team was brought to America under Operation Paperclip, a secret program to recruit German scientists regardless of their Nazi party affiliations. Their Nazi party memberships were downplayed in official records. Their SS ranks were scrubbed from personnel files. Their use of slave labor at Mittelwerk was minimized or ignored entirely. They were needed for American rocket development as the Cold War was already beginning, even before the Hot War ended. By 1950, von Braun was working at Redstone Arsenal in Alabama, developing ballistic missiles for the United States Army. He would eventually become director of NASA's Marshall Space Flight Center. He would narrate popular television programs about space exploration produced by Walt Disney. He would help design the Saturn V rocket that sent American astronauts to the moon in 1969. His Nazi past would be largely forgotten, or at least conveniently overlooked, in the celebration of Apollo's triumph. The transformation from SS officer designing terror weapons to American space hero was remarkably complete. The memory of Heinrich Maier and his network faded into obscurity. Maier's story offers a different perspective on resistance and technological transformation. Here was a man who understood rocket technology clearly enough to recognize its implications for the war's outcome, who saw that shortening the war by even a few weeks through precise intelligence would save more lives than any number of dramatic sabotage operations, who built an intelligence network that functioned at a professional level precisely because it rejected romantic gestures in favor of methodical precision, who insisted that every piece of intelligence be verified through multiple sources before transmission, who understood that technical details about fuel production mattered more than destroying a single rocket on a test stand, who paid for that conviction with torture and execution. The exact contribution of the Maier-Messner group remains difficult to quantify with mathematical precision. Intelligence work is like that. How do you measure the value of information that shapes a bombing raid, that delays a weapons program, that might have changed the strategic balance? The causal chains become impossibly tangled the further you trace them. But we know certain things. Alan Dulles credited an Austrian source with providing much of the technical information on the V2 rocket. British intelligence used that information to plan Operation Hydra. The raid demonstrably delayed V2 deployment by approximately 2 months. During those 2 months, approximately 400 V2 rockets weren't launched at a casualty rate of about 9 people per rocket. That represents perhaps 3,500 lives saved, maybe more, maybe less. But the principle is clear. Intelligence work matters, technical precision matters, methodical resistance matters in ways that are difficult to measure but impossible to deny. In the final accounting, Father Heinrich Maier's forbidden trick wasn't really a trick at all. It was a systematic exploitation of systemic vulnerabilities in Nazi security. Using Austrian officers who hated what Germany had done to their country, using industrial executives who had legitimate access to technical specifications, using couriers who could move through checkpoints without suspicion, using the fact that the Nazis never fully trusted Austrians and therefore never gave them complete security clearance, except when operational necessity demanded Austrian participation in war production. Maier understood that the system contained its own vulnerabilities, that every security apparatus depends ultimately on human loyalties, that those loyalties could be turned against the regime they were supposed to protect. This was resistance as intelligence craft, as organizational competence, as technical expertise in service of moral conviction, and it gave the Allies their first complete view of what the V2 really was. Not through dramatic defections or stolen hardware, but through patient, systematic intelligence gathering that operated inside the Nazi war machine itself.